So today we're going to use similar triangles to find missing side angles. And so what we're going to do today is we're going to make sure, first of all, that the triangle has enough information that I would know that it was similar. And so you'll notice that instead of actually giving you the angle measures, I'm going to use the geometry marks that let me know that angles are congruent. So you can see I have a single arc right here, and it matches this single arc right here. And I have a double mark here and a double arc here, which means that we know if two angles are equal, then the third one has to be equal because they have to add up to 180. And so these are automatically going to be considered similar triangles. And so I just wanted to prove it to you from the angle measure marks that that is what's happening, which means I should be able to set up a proportion like I used in 6th and 7th grade to find the missing number. So we're going to take the 36 over 24. So we're going to do like pieces. So 36 over 24 is going to be equal to, and if we put this number on top, then we would have to do the same thing with a 9. So we would have 9 over x, and then we're going to go ahead and simplify or solve it depending upon your method for doing that. I know my 6th grade people, they would have taken 9 times 4 gives me 36. Therefore, we would have taken 24 divided by 4, and we would have found out that that was 6. A 7th grade method to do that same thing would have been using cross products. So we would have taken 9 times 24. We would have divided it by 36, and we're going to end up with the same answer when we work this one out, because what we're going to find is that they have the same similar pieces in common. And so we're going to go ahead and tell that the answer here is 6. So the same thing happens when I have two triangles facing each other. Lots of times if they go ahead and draw the line here, they will tell you that these are vertical angles, and therefore they would be equal because the line in the middle would bisect it. We're going to focus on the fact that I have marked the angles. We have a right angle, and then we have this angle, and this angle are equal to each other. So clearly, even though I haven't told you, we know that this angle and this angle would have to be the same. Therefore, they are similar. What I do have to pay attention to is how I set up the proportion, because you have to make sure that you have matching parts. So if I use the two angles on the right angle, essentially the two legs, as we called them in Pythagorean theorem, I would do the height over the base. So height over the base, and then the height over the base. And again, I can use what I know about fractions, or I can go ahead and do the cross products. Either way, you're going to have it multiplied here, and you're going to divide it by 8. And so if you take 24 times 6 divided by 8, 8 goes into here exactly 3 times, and 3 times 6 is 18. So we get an answer of 18. All right, so another very common way to show you that two angles are similar will be to actually draw the triangles on top of each other. And I used this one specifically, and I made sure it was glaringly obvious. You really want to think about it like two separate triangles. So you really want to think about the fact that you actually have this larger triangle here, and how long is it from end to end? Because what usually ends up happening is someone gets in a hurry and they use this number here. But that's not the number. If I'm talking about the height of the triangle versus the base of the triangle, the first one is easy. It's 3 over 5. But you can't tell me that I'm going to do the same thing again, because clearly we know that if this is the height here, it's getting taller to get up here. It's not going to still be 3. 3 over 5 is not going to be equal to 3 over 5. So you want to think about, okay, well, the total distance here is actually a 10. So if you were just going to compare the little triangle, which is 3 and 5, then the big triangle is x and 10. And I point that out because that is a very common mistake that people make. And so clearly we can all see there that the answer is going to end up being 6. But please do not let this fool you. I made it really obvious when I used the same two numbers. But lots of times you're going to see something like 6 here and 12 here. And people are going to accidentally go, oh, well, then this is 6, when they have forgotten that clearly there was another number over here and that they should have been finding the total distance. Okay. So just make sure that they don't try to trick you on a problem like this when you see those in class. So I hope this helped. Bye.